Hello, welcome to this step-by-step tutorial on creating product analytics dashboard. Whether you're a complete beginner or looking to solidify your skills, this guide is designed just for you. Together, we will start with management key business questions, walk through building SQL queries, which is explained in detail so even a 2-year-old could understand, and finish by creating an interactive Power BI dashboard that brings your data to life. What's even better, you have access to the practice files, the SQL codes, and the DAX expressions used in this tutorial, making it super easy to follow along. With detailed explanations at every stage, this tutorial ensures you grasp each concept and feel confident building your own dashboard. So what are we waiting for? Let's dive in and start building your product analytics dashboard today. Before diving into data, it's crucial to fully understand the problem you are solving and the goals we are aiming to achieve. Imagine your company's management has tasked you to create a dashboard that answers these critical business questions. What are the total sales revenue and profits by country? Management wants to know which regions generate the most revenue and contribute the highest profit. This will help them allocate resources effectively. Next, they want to know which product categories are performing best. Identifying top performing categories help focus marketing efforts and optimize inventory management. Next, what is the impact of discounts on revenue? Discounts can drive sales, but they also reduce revenue. So management needs to assess whether discounts are helping or hurting overall profitability. And lastly, how are we performing year over year? Year-over-year comparisons reveal trends and growth patterns, helping management evaluate business progress. Additionally, the management also emphasized the need for interactive visuals for exploration. They want to explore the data by filtering it dynamically. They want to have it broken down by country, product, category, and discount band. So this granular view will help them make targeted decisions. They want to have tooltips included for additional insights. Hovering over visuals should provide extra details without cluttering the main dashboard. So why is this important? Understanding these questions ensures that every query we write is purposeful. The visuals we create are relevant, and the dashboard delivers actionable insights that aligns with the management's expectations. So what's next? In the next steps, we will prepare the data by importing data sets into a structured database. We will write SQL queries to answer each business question step by step. And then we will visualize insights using Power BI to create an interactive dashboard. By breaking this process down into smaller, manageable steps, it will ensure that even beginners can follow along and achieve the desired results. To answer these questions, we will use 3 data sets. The product data, which contains information about the product. We have the product category, the cost price, sales price, and the brand. The discount data, which provides information on discount bands, e.g. low, medium, or high, and their associated percentage. And the product sales data. It tracks sales transaction, including product IDs, the units sold, and the applicable discount band. Before we begin, the first thing we need to do is to set up the database. This involves installing Microsoft SQL Server and the SQL Server Management Studio. These tools allows us to create and manage the database we will use for this dashboard. If you've never done this before, don't worry, I've got you covered. You can watch my detailed tutorial on how to install SQL Server and the SQL Server Management Studio. The link to that tutorial is in the description below. But here is a brief outline of what you would need to do. You're going to download Microsoft SQL Server from this page. Download the Express editions for desktops. Once downloaded, run the exe file, choose the basic installation option, accept the terms, and let the setup complete. Then you will need to download the SQL Server Management Studio from this page. So download and have it installed on your desktop. It's going to let you interact with the SQL Server database. After installing the SQL Server Management Studio, open it. Take note of the server name because it's going to be needed when connecting your SQL Server to Power BI. Click Connect. So this is the tool that will be used to manage our database and run queries. Look to the left side of the screen in the Object Explorer pane. Right-click on the Databases folder and select New Database. A pop-up window will appear. Enter Product Analytics as the name of the database or give it any other name you prefer. Then click OK. Your new database will appear in the Object Explorer under Databases. Now, we are going to import each dataset into the Product Analysis database as separate tables. Here's how to do that step by step. In the Object Explorer, expand the Product Analytics database. Right-click on the database name, navigate to Task, then Import Flat File. This will open the Import wizard. Click on the Next button, then the Browse button to select your tables. We're going to start with the product data, so select that, click Open, then click Next to have the data imported. Click Next. The wizard will automatically detect the columns and suggest table settings. You can see that different data types has been assigned to each column. If you want a detailed explanation of how the data type works, you need to check the video in my description where I have it broken down into details. So I'm going to click Next because everything looks okay. Then click Finish. And we have a message confirming that the operation was successfully completed. So I'm going to close that. So now you should have the product data table listed under the database we created. If I click on the drop down for table, I should have it listed here as you see so, with all the columns intact. We're going to repeat the same process to bring in the other tables, the discount table and the product sales table. So right click on the database name, task, then import flat file. You're going to click on Next and the Browse button to select the other table. So this time we're going to be importing the discount data table. Click Next, Next, confirm that everything is okay, then Next, Finish. It's been imported successfully, so close that. Check to confirm that it's truly listed under tables together with the other one. If you don't have it shown yet, just click on the refresh button and that should have it listed. Yes, so we have the discount table and we have the product table. I'm going to quickly repeat the step again to bring in our last table. And now we should also have the product sales table listed. So click on the refresh button. Check to confirm that we truly have it listed. Yes, so we have all our three tables listed under tables in our product analytics database. Now, after importing data sets, it's essential to verify that the data has been correctly imported. We're going to take this step one query at a time. So open a new query window by right-clicking on the Product Analytics database, select New Query. This will open up a blank query window where we can type our SQL commands. We're going to start typing the verification query. Let's start with Product Data Table. So I'm going to type in this query. This command tells SQL to retrieve data from a table. Top 10 limits the results to the first 10 rows of the table. This is essential when you want to preview data without retrieving the entire table. The asterisk means all columns, and from product data specifies the table we are retrieving data from. Now we're going to execute the query by pressing F5 on your keyboard or clicking the execute button up here. Now you need to check the result to ensure the data matches the product data file. You can see that we have just 3 entries, even though I had entered top 10. This is what we have in our actual file. We have just 3 entries, so that is fine. But in cases where you have so many entries in your table, the select top 10 option will only display top 10 results from your table. Now to verify the other tables, we're going to repeat the process. For discount table, we just have to replace this name with a discount table name. Select that from the option below and execute. And now you can see that we have the top 5 entries in our discount table name. And all the entries appears correct with what I have in the file. For product sales, do the same. Replace discount table with the product sales table name. Select that from below and click on the execute button. And I can see that everything looks fine. So what are the things you want to look for in verifying? You want to ensure that the column names match the CSV file headers. You also want to verify that the numeric fields like prices and units sold are correctly recognized as numbers. And check for any missing or misaligned data. So by the end of this step, you will have a fully set up product analytics database. You will have 3 correctly imported tables: your product data, your discount table, and the product sales table. So the purpose of this verification is to ensure that the data is accurate and ready for querying. Next, we will move on to writing SQL queries to transform and analyze the data step by step. Now that we understand the structure of our data, we will start combining tables to create meaningful insights. The first step is to join sales and product data. To analyze sales revenue by product, we need to combine the product sales and the product data tables. Here's how to do that step by step. In your query editor, clear any previous query so we start afresh. And I would have this query typed in. This query combines data from the product sales and the product data table to provide a unified view of sales transactions alongside product details. Let's break it down step by step. The select command specifies the columns we want to include in the final result. The columns selected in this query are from the product sales table, which has been aliased as PS for ease of reference, and from the product data table, aliased as PD. So from the product sales table, we want to select the transaction ID column, which is the unique identifier for each sales transaction. We also want to select the date column to allow us to analyze trends over time. We want the country column and also the customer type column. Then from the product data table, we want to select the product column and the category column. Now moving on to the calculated columns. This removes the dollar symbol from the cost price column, preparing it for numerical operations. The cast and the as float function then converts the cleaned up value into a numeric data type float, suitable for calculations. And this renames the column in the output as cost price for better readability. Similar to the cost price, this transformation cleans and converts the sales price column into a usable numeric format. This renames the column in the output as sales price for clarity. And if you come down here, this command selects the number of units sold in each transaction. The data is crucial for calculating total sales revenue in later steps. And from the product sales PS, specifies the main table for her query, which is the product sales. It assigns this the alias PS. Using aliases simplifies column references in the query, especially when dealing with multiple tables. And down here, the inner join combines the product sales and the product data table using an inner join. And finally, this part matches the product column in the product sales table with the product ID column in the product data table. So why do we use inner join here? An inner join ensures that only rows with matching values in both tables are included in the result. This is important because we want to exclude sales transactions that do not have corresponding product details. Now let's click on the execute button to run the query. If I have this opened up, we should have the result shown here. So this query produces a data set that combines sales transaction data, e.g. the transaction ID, the date, and the customer type, with detailed product information, e.g. product name, the category, the cost price, and the sales price. So this unified view will set the foundation for calculating revenue and profit in subsequent steps. Now, we need to add a calculated column for revenue. You can either start a new query or build on this previous one. I'm going to have this previous query modified to include the calculation for revenue. So right below here, after the calculated measure for sales price, I'm going to include the measure for calculating revenue. So now let's break down what has been added and why. This measure calculates the total earnings, that is revenue, for each transaction by multiplying the numeric sales price by the number of units sold. Again, the replace function removes the dollar sign from the sales price, leaving only the numeric portion as text. And why do we remove the dollar sign? SQL cannot directly perform calculations on text fields containing symbols like dollars. Removing the symbol ensures the value is clean for processing. And the cast as float function converts the cleaned sales price into a floating point number. Numeric data types are required to perform mathematical calculations like multiplication. And then this multiplies the sales price by the number of units sold for each transaction. We are doing this because it gives the total revenue for that specific transaction. And finally, as revenue, assigns the calculated column a descriptive name, revenue, making it easier to reference in the results of future queries. Now, revenue is a key performance indicator, allowing businesses to track earnings by product, category, country, or customer type. With revenue now calculated, it becomes possible to derive other financial insights, such as the profit, the discounted revenue, and the year-on-year growth in the later step. Now we're going to execute the query to verify that the revenue column appears and is calculated correctly for all transactions. So click on the execute button. Now we need to check, what are the validation checklists? Does the revenue column show accurate value based on the sales price and the units sold? Yes. Are there null or unexpected values in the results? No, we don't have any. And does the format of the output meet the expectation? Yes, it does. So it all looks exactly as we expected. Next, we're going to incorporate the discount data table to calculate discounted revenue. Again, you can either start afresh with a new query or continue with the previous one by updating it. So I have updated the query to include the discount data using the left join and a calculated column for discounted revenue. This allows us to analyze revenue after applying discounts, which is crucial for assessing the effectiveness of promotional strategies. Now, here is a detailed breakdown of what has been added and why. The DD discount retrieves the discount rate associated with each transaction from the discount data table. Discounts are grouped into bands, e.g., low, medium, or high. And how is it used? So this value is used in the calculation for discounted revenue. The discount is matched with the correct transaction using the discount band column. And with this calculated measure, an adjusted revenue value, that is the discounted revenue, is calculated, reflecting the true earnings after promotional reductions. The first step in the process is to calculate the initial revenue using this measure. This part determines the discount amount and subtracts the discount from the total revenue. And the as discount revenue assigns the name discounted revenue to ensure clarity when reviewing the query results. And going down to the left join has been used to link the discount data table with the product sales table using the discount band column. Now, why use a left join? Left join ensures that even if a transaction doesn't have a discount, it's included in the result with the discount percentage defaulting to null. Now, to summarize the change, a discount percentage column has been added. For discount integration, we subtracted the discount amount from the total revenue to calculate discounted revenue. And we used a left join to incorporate discount data while retaining unmatched transactions. So this update matters because the inclusion of discounted revenue provides a clearer picture of profitability, which helps management understand the impact of discounts. It's also a good foundation for further analysis. Metrics like discounted revenue can now be analyzed by product, category, or country in Power BI. Now let's run the query and test it for validation. Now, if you check the results we have, you will notice that the discount percentage and the discounted revenue column are populated correctly, and all transactions without discounts still appear. With the discounted revenue equal to the actual revenue, there are no discounts applied. And for the ones with discounts, you will notice that the actual revenue figure is higher than the discounted revenue because the discount of 6% in this case has been applied. So everything looks correct and it's reported as expected. We are done with creating the SQL measures. Now the next step is to connect the SQL Server to Power BI. And why are we doing this? Power BI allows us to visualize the data dynamically, making it easier to answer management questions interactively. Now, to connect to Power BI, you're going to need to open Power BI. So launch Power BI Desktop from your computer if you have it installed already. We're going to start with a blank report. So select that. So this is the tool we are going to use to create the dashboard. Now in this Power BI interface, click on the Home tab, locate and click on Connect to Data or Get Data. From the drop-down, select SQL Server Database. This tells Power BI where to pull the data from. Then click Connect. In the pop-up window, for the server name, you're going to need to enter the name of your SQL Server. If you're not sure how to get this, go back to your SQL Server Management Studio. Click on the Connect button on the left here and select Database Engine. And that will give you the pop-up that has the details of your server. So right here, we have the server name. Just have that copied and paste it into Power BI. For database, type Product Analytics. That's the name we gave to the database we created in the SQL Server. Expand the Advanced Options section in the connection window and copy and paste the final query we have here for step 3. So I'm going to select all that, copy it, then have it pasted here. This ensures Power BI pulls only the prepared data we've queried. Now load the data by clicking OK to connect. Click Connect again. Now Power BI has executed the query and displayed a preview of the data. All you have to do now is to click the Load button to import the data into Power BI. Once the data is loaded, navigate to the Fields pane on the right-hand side of Power BI and click on the drop-down for the query to ensure that all the columns from your query, e.g. the date, the country, the revenue, and the discounted revenue are available. So we have everything here as expected, just as we have it reported in our SQL Server Data Management Studio. With this step, your SQL query results are now connected to Power BI, ready for visualization. Now that our data is ready, let's move on to creating the visuals for our dashboard. We will work on this one by one, ensuring everything is clear and aligned with management's goal. Let's start with a bar chart to visualize revenue by country. This will show us which markets contribute the most to overall revenue. So, in the visualization pane, let's locate clustered bar charts. That's what we're going to use for this visual. In the Fields pane, drag country to the y-axis and revenue to the x-axis. This will show us the markets that contribute the most to the overall revenue. To format and style the visual, I'm going to click on it. To have the format visual activated, turn off grid lines to make the chart cleaner. So go to the y-axis and toggle off the show grid lines option. And I'm going to format the bars to have different colors to represent each country. So if you scroll down and click on the drop down for bars, have each country selected and give it an appropriate color. To give the chart a title, go to the General tab, click on the drop down for title, and have that renamed to Revenue by Country. So just remove the sum off. You can have the title formatted further by making it bold and align it horizontally. You can also have the font increased a bit if you want to. So I'm going to make this smaller and have it positioned in the top left corner of the canvas. We don't need this title on the Y and the X axis, so let's have that turned off. Under the Y axis, turn off the toggle for the title option and repeat the same for the X axis. Next, we will create cards to highlight key performance metrics, including total revenue, total units sold, and profit margin. These cards will provide a quick snapshot for management. So to create that, I'm going to grab the card visual from the visualization pane here. For the first card, drag revenue onto the canvas. So I'm going to open the fields pane and drag revenue to the card visual. In the Format Visual under the General tab, toggle on the title option and give it a name, Total Revenue. You're going to make that bold, increase the font size, and align horizontally to the center. Repeat the process for units sold. So you can just simply have this copied and have revenue replaced with the units sold field. Now for profit margin, I'm going to have it copied and pasted again. For profit margin, we need to create a DAX measure. So we're going to be creating DAX measures in Power BI. DAX measures allows us to perform advanced calculations such as year-over-year analysis or profit margin, which are not directly available in our dataset. To get the DAX measure for profit margin, open the Modeling tab in Power BI's ribbon at the top of the screen and click on this option to create a DAX expression that creates a new column in the table. Here's the DAX measure we're going to use to calculate profit margin. I will quickly break this down. This part of the formula calculates the profit by subtracting total cost from total revenue. The divide function safely divides profit by revenue to calculate the margin, using 0 as a fallback if revenue is 0. So click on this check option to have the query committed. We have an error which says the sum function only accepts a column reference as an argument. That's because we haven't referenced these columns directly. To fix that, let's just change this to make sure it's selecting the columns directly. So for revenue, I'm going to select query 1 revenue. For cost price, just start editing it and you get the option to select from below. And for the sum revenue, start editing as well and select the column directly from the table. And that should solve the problem. So let's commit that again. And now we have the profit margin measure calculated and added as a field on the right here for us. So I'm going to have this calculated measure dragged into this card to replace revenue. The name needs to be changed. I'm going to have this changed to units sold by opening the visualization pane under the General, click on the drop down for title and have this title changed to units sold. And do the same for the profit margin. We're going to have the category label turned off. We don't need that. It's just taking up space. So I'm going to have that option toggled off. Do the same for this. I'm going to assign subtle background colors to differentiate the cards visually by going to the filter options under General, click on the drop down for effects and choose a color of your choice. You can also toggle on the visual border option just for some separation. Give it rounded corners by increasing this option to 4. We can increase it further to say maybe 8 or 10. And do the same for the other visuals, but with different colors. You can have the size of the callout value reduced for all just to create some space. So let's have this reduced. Let's have this reduced to 30. Do the same for the rest. And have the size of the cards reduced further just to create more space. And then I'm going to bring this down a bit right below the cards. Our third visual is a donut chart to display the impact of discounts on revenue. This will help us understand how each discount band contributes to overall discounted revenue. So from the visualization pane, select the donut chart visual, drag discounted revenue to the values field, and drag discounts to the legend field. Rename the title to Impact of Discounts on Revenue. You can also decide to give the visual a border just to make it stand out. But before then, let's further format the name, the title, so we can have it increased just to match with the other titles. Make it bold and have it horizontally aligned. Now let's have a border added to the visual. Under the General tab, go to the Effect, turn on the Visual Border option. You can decide to give it any color you wish to. Let's see what this looks like. Yeah, we'll do the same to this visual. Under the Effects option, turn on the Visual Border option and give it the same color. Or maybe something else. It really depends on your preference. Yeah, I think I'm gonna go with the purple visual, the purple border color. So now let's have the chart resized and have it placed below the bar charts in the left column. Now, we will create a line chart to analyze year-over-year trends in revenue and profit. This will help management understand our growth trajectory. We are also going to be creating DAX measures for that. So first, let's calculate the year-over-year metrics using DAX. Open the DAX measure again by going to the Modeling tab. Click on the option to have a new DAX measure calculated. So instead of year-over-year metrics, we're going to be calculating month-over-month metrics. We already have a month column in our data set from the date hierarchy created automatically by Power BI under Date. We're going to need the DAX formula to create that. So click on the Modeling tab, New Measure. This is the same measure we used in calculating the year-over-year earlier, except that previous year has been swapped with previous month. So let's have that committed. And with that, we have our month-over-month revenue listed as a field here. So now let's have the relevant measures added to our line chart. I'm going to have the date column from the new date table created to the x-axis of the chart and have revenue plus the calculated month-on-month revenue dragged to the y-axis. So I'm going to quickly have this formatted like we did to the other charts. I'm going to turn off the titles of all the axes just to create more space. Rename the title of the chart to just revenue and month-to-month revenue by date. Increase the font to match with the other charts. Make it bold and have it horizontally aligned. To save time, I will quickly copy the formatting of this chart here and have it applied on this new chart. You can decide to change the color for each measure if you want, but I think I'm just going to leave this as it is, or even change it to something to match the whole dashboard. You can do that by changing the line color. So for the series, I would select for the sum of revenue, have the color changed from blue to maybe pink, and do the same for the month-to-month revenue line. So instead of blue, we can have it changed to something else, or just leave it as it is. But if you want to have the color changed, this is where you do that. So I think I'm just going to leave it as purple. And there you have it. Since we have enough space on the canvas, I'm just going to move things around a little bit just to make good use of the space we have. So let's move these two bar charts up, and we have this extended to show more results. And now we're going to add interactivity to our dashboard by adding slicers. Interactivity allows users to explore the dashboard dynamically, filtering visuals to answer specific questions. So let's get a slicer visual, then drag fields like product category to the slicer and have the slicer formatted to be displayed in another style. So if you click on the slicer settings drop-down, options, and change it from vertical list to tile. Just adjust that, have the size increased like so. This can also be further formatted to make it more visually appealing. Let's have the values increased to make it bold, and have the title formatted as well. That's the header, so let's have that increased and make it bold. And we can have the slicer duplicated by simply copying it and pasting for another slicer. So instead of the category, let's say we want to have a slicer included for countries. Have the size reduced so it fits somewhere here. You can decide to make the formatting just like this. Just going to quickly amend this in the background so I don't end up wasting time on formatting. Now that our dashboard is coming together, let's have it enhanced with dynamic tooltips. Tooltips will display detailed contextual information when users hover over visuals, providing additional insights without cluttering the main page. We will create a dedicated tooltip page, design it, and link it to the main visuals dynamically. So let's start by adding a new page for the tooltip. Go to the bottom of Power BI and click on the plus button icon to add a new page. Rename the page to Tooltip by double-clicking the Page tab and typing Tooltip. Next, we will format this page to serve as a tooltip. So open the Format pane by clicking the Paint Ruler icon. Under Canvas Settings, change the page size to Tooltip. Under Canvas Background, set the background color to a light gray or white to ensure readability, and have the transparency adjusted to about 20%. Now, we will add the contents to the tooltip page. Have a card added for total revenue and drag the revenue field into that. Then go to the Format pane. Under Title, give it a name Total Revenue. Reduce the font size and have the card itself reduced to create more space for other cards. So I'm going to reduce the label size as well. So if we go to the callouts value, let's have this reduced in a big way. And let's also get rid of the category label just to have more space. So now let's copy this and have it pasted for another card. But this time we're going to drag discounted revenue to the field. So let's remove this and replace it with discounted revenue. We're also going to add a table for a detailed matrix. So insert a table visual from the visualizations pane. Drag fields like country, the product, and profit margin into the table. You can also have specific columns on the table formatted by making a selection here. For instance, if you select on sum of profit margin, you can decide to have data bars added to it, change the font color, or add icons. Next, we need to link this tooltip to the main visuals. Go back to the main dashboard page. You can quickly give this a name, Dashboard. Select the first visual you want to have the tooltip linked to, such as the revenue by country bar chart. Open the Format pane. Under the General tab, expand the Tooltip section and have the tooltip set to Report page. And from the Page drop-down, select the tooltip page you just created. Repeat this process for the other visuals, like the donut chart go to the Format pane and have this changed to the Tooltip page. Now, when you hover over a visual, the tooltip will dynamically show the relevant data for the selected element. If you try that with the donut chart as well, you get the same result. So if, for instance, you want to make things look more beautiful, you can decide to give this a background just to make it a bit visually appealing. So click on the effect and have this changed to this. I'm going to have the total revenue changed to maybe purple and have the entire table changed to something else. Maybe not. Maybe this. No? I mean, you can play around with the colors and just give it whatever you feel comfortable with. So I've decided to change these colors and let's see what it looks like. I feel like the colors were too bright. So if you hover over any of the elements here, this is what we have. You can see how it's changing dynamically to match with the element. The same with the donut chart. So this is definitely a better way to show more reports without cluttering the dashboard, if you get what I mean. And to improve the overall dashboard design, let's give it a background. So open the Format pane, click on the Canvas drop-down, the drop-down for color, and select any color you deem fit. So if we bring the transparency down a bit to this, we'll see what we have. So you can play with any of the colors to decide on what suits you best. This is looking more like what I would like to go with. But I think let's play down the colors just to make it look professional. So if I go with this or this, I mean, anything you feel comfortable using. You could go with a color that matches with your company's theme. The options are there for you to choose from. I could just go with a really dark black. And that's it, guys. And that's a wrap. You've successfully built a product analytics dashboard from scratch, starting with SQL queries, transforming the data, and visualizing insights in Power BI. Great job! Now you have the tools and knowledge to create interactive dashboards that provide actionable insights for any business. If you found this tutorial helpful, don't forget to like, comment, and subscribe to stay updated with more beginner-friendly guides. And remember, you have access to all the practice files, the SQL codes, and the DAX expressions we used. So feel free to revisit and experiment at your own pace. Have questions or want to see more tutorials like this? Let me know in the comments below. I would love to hear from you. Thanks for watching, and I'll see you in the next video.